Hi and good day. Today we're going to look at Chapter 3, Section 1, and it's all to do with compound interest. Right. Now if we just sort of summarize the first chapter, we looked at simple interest and simple discount. And with simple interest and simple discount, we had one principal and the interest were calculated once during the whole period and then added to the principal value to give you the future value. Now with compound interest, it's a little bit different. Again, we've got one principal value, but interest is calculated more than once according to the number of compound periods that is specified. For instance, let's say I've got, let's just go back. Okay, we're ready. Right. With simple interest, remember as I said, it was SSP1 plus RT, and with simple discount, we had 1 minus DT. And our interest was calculated once. In the case of simple interest, we added it to the principal value to give our future value, and with simple discount, we take our value and we subtract the interest or the discount, and we get our principal value. Now, if we think of just little blocks being, that is our principal value. In the case of simple interest and simple, or let's just look at simple interest, our interest was calculated on our principal value. It was added to give us a bigger amount there. What happens with compound interest? Let's say we deposit or invest 15,000 Rand at an interest rate of 10% per year, and we say it's compounded, let's say monthly. What does that mean? It means that at the end of every month, interest is calculated on the amount. So let's say we start with our little block. At the end of the month, interest is calculated on that amount. But now you must be careful. What do we know? It's 10%, our interest is per year. So to make it monthly, we take our interest and we divide by the number of times that compounding will be made in 1 year. So if we say compounded monthly, it means there's 12 times in 1 year that the interest will be calculated. So we take our 10%, which is a per year rate, and we divide it into 12 smaller pieces. That's the first thing. So what happens at the end of the month is the interest is then calculated on that amount. It's added to it. So the next month we've got a little bit extra. It's got our principal value plus our interest. Come the end of the next month, interest is then again calculated, but can you see the principal value is now a little bit bigger because this interest is calculated on the principal plus the interest of the previous month. Come the third month, we have our principal plus our two little interest pieces, and we calculated again our little piece of interest on our principal, but now our principal is even bigger. So what's happening here is interest is calculated in shorter periods than a year. It can also be years, but normally it's smaller than years. And the interest is actually calculated not only on the principal value that we started off with, but every time, or the new month or the new week, it includes the previous interest. So what are we getting here? We actually earn interest on interest as well. So in this instance, our investment grows much quicker than with just simple interest. Our formula looks a little bit different. Remember, simple interest was RT, R being our simple interest rate, T the time. Now, because we're earning interest on interest, our interest component changed a little bit. I'll explain all the values to you now. Okay, S is your future value, P is your present value. Now JM is your interest rate per year, or also what we call the nominal interest rate, the rate per year. Then M is the number of compounding periods in 1 year. Very important. So it's the number of comp periods, I'm just using abbreviations, per year. So if I say the interest rate is compounded monthly, then M will be 12 because you will do the compounding 12 times in 1 year. If it's weekly, how many weeks in a year? 52, so M will be 52. Right. Now your time period changed a little bit as well. The time period is now T times M. Now what does it mean? And what is T and what is M? If you look at this, the interest, we've taken the yearly rate and we divide it by the number of compounding periods. So what did we do with the interest rate? We made it smaller little pieces of interest rate almost. Now, can you remember T is years? Now the time and your interest rate, time and the interest rate always goes together. So if this is smaller pieces, we need to make our time period also smaller pieces. So the T stays the number of years or fraction of the years, but we multiply it with M, which is the number of compounding period. So what does TM actually gives you? It's the total number of compounding periods in the full term of that investment or for the borrowing the money. Happy with that? So T always be in years or fraction of years. M being the number of compounding period per year. So it means 1 year only. Now how would I ID a compound interest type of problem? The words compound interest, and there will always be one principle as well as just the word compounded. So when you see compounded, you must know you're working with compound interest. With the calculator, that's very nice. We can use our financial mode instead of just our normal mode. Okay, let's look at our first question. Question 1, remember again, we've got our cake recipe that I always say. You read through the question, decide if there's an ID word that will give you indication of what type of problem you're working with. Now remember, simple interest, the ID word was simple interest. With simple discount, it was simple discount or simple discount rate. With compound period, we're looking for the word compounded interest rate or the word compounded. So let's read the question. Susan deposits 15,000 into a new savings account. The amount of money that you will have in the bank after 3 years, if interest is compounded monthly at 8% per year, equals. Now, if we read through that, is there any words with simple interest? No. Is there any word of compound interest? Simple discount? No. Is there a word compounded? Yes. So at this stage, we think it will be a basic compound interest formula or problem. So we write down S equals P1 plus JM over M. We just call the interest rate JM, which is a nominal interest rate. It's a yearly rate, right? To the power of T times M. Right. Now, firstly, we then draw our timeline. Right. She deposited 15,000 when? Now. Right. Right there. Now. The amount of money that she will have in the bank after 3 years. So we know that is 3 years. And we want to know what is the size of the loan. If interest is compounded monthly at 8% per year. So you know your interest rate is 0.08, right? Or 8% if you want. Remember, how do I get from a percentage to a decimal? I divide by 100. So that gives me 0.08. Remember to use the 0. If you've used 0.8, that would have been 80%. Okay, be careful for that. So it's 0.08, but because it's compounded, we must divide it by m. And what is m? M is the number of compounding periods in 1 year, in 1 year only. So if it's monthly, how many months in a year? 12. So there's your value. Right. We know it's a compound interest formula. There's our formula. Now we need to go and substitute it in. P is 15,000. 1 plus Jm is 0.08 over 12 to the power. T, what is the time period? It's 3 years. So it's already T is in years. So it's to the power of 3 times. And what is M? M is how many compounding periods in 1 year? It is 12. Right. Now, you can use your calculator normal mode by just entering it as it is, or you can make use of your financial calculator keys. Now, on your keys, you will see there's an option which says future value, present value, payment, there's an interest rate, there's a per year, and there's an end value. Now, this over here is then what we call our present value. That 15,000 is the present value. The 0.08 is what we call our interest. Depending on which calculator you're using, it's either that or the one which is the YR at the back. The 12 we call the periods per year, depending again what calculator you're using, right? And then the 3 times n is our n value. What do we want to calculate? S. So after you've entered these in your calculator's little boxes, you just then press your future value. With the one you say comp future value, with the other one you just press future value to give you an answer. Let's quickly look at our notes. There again is the cake recipe. I normally just include it for you to make sure where you are. We've read through the question compound monthly. We've drawn our timeline. We've written down the formula. We identified the values. And there's our calculator keys. S is your future value, 15 your present value, 0.08 your interest rate. Now you must just be careful. The interest rate, when you enter it in your calculator's financial mode, you use it as a percentage. So you would, in this instance, when you enter it in normal mode and you do the calculation from left to right, you use your decimal as 0.08. Have a look at your calculator booklet, which we included on your additional resources, or look at the video on your calculator to see how to do this calculation on your calculator. Okay, next one. Let's look at this one. Harry's parents think that they will need 170,000 to pay for his university fees in 15 years' time. They invest money at 7.71% per year, compounded quarterly, determine the amount that they need to invest now. Again, is there wording simple interest? We first got to ID it. No. Simple discount? No. But there's the word compounded quarterly, right? So in this instance, again, we're busy working with compound interest. Again, firstly, we write down our formula. Right, next, we draw our timeline. Why do I always draw a timeline? Because it helps you to identify the time. They will need 117 in 15 years' time. Right? They invest the money at 7.71 per year. So remember, if you're working with percentage, right? And it's compounded quarterly. Now, quarterly, what does quarterly mean? Quarterly means every 3 months is a quarter, right? So there's 4 quarters in a year, right? So how many times would we compound it? 4 times. So quarterly or every 3 months is exactly the same, right? So there we've got it, or you can write it as O, remember 071 divided by 4. And what do we need? We need the present value that they want to invest now. Right. So if we go back and we need to substitute it in, S is 170. Equals, what is your p-value? We don't know. 1 plus our interest rate is 0.071 divided by 4. And our power, T is years. Is the 15 years? Yes, I used it. But we needed smaller pieces, so I multiply by n, which is 4. Now, if you do this in normal mode of your calculator to calculate p, you need to take this piece over to the other side, so 170 divided by that whole interest component will give you your p-value. Using your financial keys on your calculator is so easy. You don't have to change it. All that you need to do is fill in or put the little, I always say put it in the little boxes of your calculators. So for instance, the 170 is your future value. Your P you don't have. P is the present value. Your 4 is your per year or per year R, your periods per year. Your 5 times 4 is your N value. And your 0.071, just be careful, remember, you enter your interest rate as a percentage, right, is then your interest. Last thing that you would press is either comp your p-value, your present value, or just, in the case of the HP calculator, just present value. Right. So it's very easy, if you've got the financial calculator, to solve a problem like this without manipulating the formula. So there we've got compound interest, what's principal, we've got all our values, and we use our financial mode. Guys, you can use a normal calculator, but it will take a lot of time, especially in the exam. So I would recommend that you buy a financial calculator. So there it is. We'll enter the future value. We enter the interest rate, remember as a percentage, your period per year, and or number of periods per year, and your N value. Right. Now the next subject that we're going to look at under compound interest is effective interest rate. Now, if you think of compound interest, remember we said interest is actually earned on interest, right? Why? Because the previous compounding period interest is now added to the packet or the principal that we forward. Now, if we say our nominal value, meaning our interest rate per year, is 10%. Now remember we said That 10% is firstly made smaller, but you get interest on interest. Now what do you think at the end of the day after a year? Would you have earned only 10% or pay 10% interest, or would you have paid more or less? You would have actually paid more. So you earn more than the nominal interest rate on your money in 1 year. And that is what we call the effective interest rate, meaning what in effect am I earning in 1 year? The formula, if you can look at it, it's basically just your interest component. So the effective interest rate, the 100 is just there to give you the percentage. 1 plus JM over M times M. So can you see this is just the interest component for 1 year, right? If you look at our formula, if T is 1, that falls away, which gives you your M. If T is 1, it will give you your M. Right. So if we look at 1 year, it will just look at that there. And that gives you then, if you calculate that, it will give you an answer like 1,45 or whatever. To get that 1 away, it's that why we've got the minus 1 and multiply it by 100 to get our interest rate. How would I know if I'm working or I need to use this formula? If you see the word effective interest rate in a problem, that is your ID clue. Calculator, financial or normal mode. Just be careful. If you use normal mode, remember to put all your brackets. Otherwise, you will get a different answer. Let's look at an example. Determine the effective rate for a nominal rate of 18.75% per year compound every 3 months. So you can see there's the word effective rate, but also nominal rate. So it's actually, you can say, writing the one in terms of the other, but we know the ID word is actually effective rate. So we've got the word effective rate, so we know the ID. Secondly, we can write down our formula. Where JM is our nominal rate. Okay, what is our nominal rate, JM? It says 18.75% per year, or if you want to write it as a decimal, 1875. What is M? M is the number of compounding periods in a year. In this, it's compounded every 3 months. Meaning, if I've got 12 months in a year, every 3 months, so how many times 12 divided by 3 would give me 4. You can also write it as 12, that's a year, months, and there is every 3 months. So actually it's nothing else than compounded quarterly. Right, so now we can substitute it into our formula. 100, give out the percentage. JM is 0.1875 divided by our M, and that is 4 to the power of 4 minus 1. We can use again our financial mode as I've discussed previously, as well as your financial mode. And that gives you an answer of 20.11%. So even though the nominal rate per year was quoted as being 18.75% per year, what did you earn on your money actually effectively? Because of the interest that's earned on interest, it's 20.11%. So effectively, remember, is what you earn in 1 year. Right, last question. Determine the nominal rate per year compounded monthly for an effective rate of 20.75%. Again, what is the ID word? Effective rate. But they now want the nominal rate. So the moment we see effective rate, we write it down. Our formula. Oops, sorry. It's just M, right, minus 1. Okay. What is given to me? The effective rate is 20.75. So it's 20.75, right, percent equals 100. 1 plus JM we need to calculate, right? Because it's asked the nominal rate per year. M is compounded monthly, so we know the 12 minus 1. Now again, you can go and manipulate this formula to get to an answer for JM, right? But because we've got exponents, you will use your linen log rules from school to get to an answer. But luckily, you've all got your financial calculator, and you can just enter the values you have and choose at the end your IY value, which is then your interest rate. There is our formula. We've entered everything. Again, do not change your formula. Your calculators, financial mode can do it for you. And the nominal rate is 19%. So effectively, if you've got a nominal rate of 19% that you earn per year, effectively in 1 year, you actually earn more, namely 20.75%. Right, that concludes then the first part of Chapter 3, Section 1.